Okay, so after going over radical equations, next we're going to see some applications of radicals in 9.6. The applications of radicals that I'm going to go over is the first one is the Pythagorean theorem. Which discusses right triangles. Okay, any right triangle, a triangle with a 90 degrees angle, the square of the hypotenuse. Hypotenuse is, we use C to demo the length of the hypotenuse. It's usually the longest side of the right triangle. The two sides are called legs. They're the shorter sides, leg A and leg B. The square of the hypotenuse equals the sum of the squares of the legs of the right triangle. So C squared equals A squared plus B squared. Remember, this is always going to be the bigger, okay? And these are the smaller values. And it's not, we're not saying C equals A plus B. That's not what I'm saying. If you square root, you don't get A plus B. Square root of A squared plus B squared does not equal A plus B. Okay, so what this means, given any two sides of a triangle, whether it's a hypotenuse and a leg or two legs, we can find the third side. That's what this is all about. But you have to have a right triangle to do that. So for example, if I give you this, if I say given the triangle, and the triangle is labeled as CAE, so you're given A equals 10 centimeters, C is 26 centimeters, you need to find B. C being the hypotenuse. So again, the Pythagorean theorem, C squared equals A squared plus B squared. 26 squared, remember C is 26, A is 10, and B is the unknown. So if you do 26 squared, you get 676. That's 100. To isolate B, or B squared, you get B squared is 576. When you square root, it's usually plus or minus, but B cannot be negative, and it's 24. And don't forget to attach the right units to your answer. Okay? Here's another example. Again, same kind of a triangle, CAB. You're given A equals square root of 15 feet. B is square root of 21 feet, and now you want, so you're given the two legs, you need to find the hypotenuse. Same formula, C squared equals A squared plus B squared. A is root 15, but it's squared, and then root 21 squared. That takes care of the squaring, so we got C squared is 15 plus 21 is 36, so C is root 36, which is 6, and the units are in feet. And remember, C has to always be bigger than A and bigger than B. Okay, now if you look at your notes, there is the 45, 50, 90 degrees triangle, and then the 30, 60, 90 degrees triangle. We're gonna skip that. We won't need these until we go to trig, and I'm not gonna go over them now. Okay, so skip page 63 and 64 from the notes. The next application that I want to talk about is the distance formula. The distance formula. So look, if we're talking about distance on the number line, it's easy. Like if you have a number line and you want to find the distance, say between point A, which is at 1, and point B, which is at 5. That distance is 4 units, right? 2, 3, 4, 5. So distance is 4, which is actually 5 minus 1, 4 units. Now if you have point A, point B, and I say find the distance and you don't know their value, all you want to say is B minus A, bigger minus smaller. Now if I say find the distance between A and B without giving like position, then you do absolute value to make sure that distance is positive. Like distance would be absolute value of B minus A, or absolute value of A minus B. If I don't specify their location, you want to make sure that distance is positive because you don't know whether B is bigger or A is bigger. Okay, that's if we're dealing with the number line. If we're dealing with the rectangular system of coordinates, that's what we're dealing with right now. 2 dimensions system of coordinates. So basically we're looking for any 2 points, A and B. I'm just gonna put them in the first quadrant for simplicity. We want this distance, that's point A, say it has an X and a Y value. We'll label them as first and second. First values for A, second values for B. And we want to find this distance. So to do this, we want to make a right triangle to use the Pythagorean theorem. So we start at A, we move to the right until we reach a point C, then we go up to reach point B, so we get a right triangle. We want to find the hypotenuse given our numbers, so we know this distance is that distance, which is x2 minus x1. We just talked about the distance on the number line, and this is y2 minus y1. So using the Pythagorean theorem, d2 is x2 minus x1 squared plus y2 minus y1 squared. C squared equals a squared plus b squared, but we want the distance, so we square root it, and that's what we call the distance formula. And again, this formula, as well as the Pythagorean theorem, listed in the handout that I showed you at the beginning of 9.5. So 46, page 797. It says find the distance between the points -5, -2, and 7, 3. Again, the question is to find the distance, so we're going to use the distance formula. We label the points first, then we write the formula down. Square root of x2 minus x1 squared plus y2 minus y1 squared. We plug the numbers in. 7 minus -2 squared plus 3 minus 7 minus -5 squared. Okay, x2 minus x1, and then 3 minus -2 squared. So that's 7 plus 5, which is 12. 12 squared. That's 3 plus 2, which is 5. So it's 5 squared. So 144 plus 25. And the last thing we want to do is square root it, and that's 13 units. So basically, if you're just wondering what we just found, you don't have to draw the graph, but I'm just doing the graph to explain what just happened. -5, -2, this is point A, and then 7, 3, this is point B. We just found the distance, diagonal distance between these 2 points to be 13 units. And the unit here is how much hash mark you have on that. That's it. Alright, number 50 from page 797. Again, find the distance between 2 different points now, -3 and 4, -8. So label the points, x2, y2, write down the formula, x2 minus x1 squared plus y2 minus y1 squared. So 4 minus 2 squared plus -8 minus -3 squared. That's 2 squared plus -8 plus 3 is -5. But remember, when we square a number, we get a positive. So 4 plus 25. Now you can leave the answer in exact form, or you can just put it in your calculator. Watch for the question, what it says. Okay? Do they want to round off to 1 decimal place, 2 decimal places, or do they want the exact answer? Make sure you answer that question. Now I want to show you an application on the distance formula before we go to the midpoint formula. So we're going to page 798. Make sure you go there. Number 74. Page 798. Number 74. 798. Number 74. Yeah, I usually don't do this class because I usually don't have time, but technology allows me to have time now. So find the height h of the ironing board shown in the illustration gives the exact answer and approximation to 2 decimal places. So they want the exact answer and they want an approximation to 2 decimal places. Let me copy what they have there so we can do the work. So we have and what we know is we have a 30 degrees. Okay, wait a second. This is split up. So we have a 30 degrees right here. And since this is 90, then this must be 60 degrees. And we also have 60 degrees here. According to the picture, this is 90, this must be 30 degrees. So we have 30, 60, 90, 30, 60, 90, and we want H. So let's label these as H2 and H1. So H is H1 plus H2. And actually to do this, we need to know the 30, 60, 90, which we didn't go over, but that's fine. Yeah. I'll just give you more if I ask you something like this. So H1, which is the side that's opposite to 60, which would be 14√3 inches, and H2 would be 6√3. Because I'll tell you why. Because this is we're given this is 28 inches, and this one is 12 inches. And this is 60, this is 60, this is 60. So this is an isosceles triangle, so this must be 28 inches. This is equilateral triangle actually, 60, 60. And this must be 28 inches. So basically 28, so half of it is 14. So that's 14, that's what the 14 comes from. Same over here, this is 12. It's a 12 inches. So it's 6√3 because that would be a 6, okay? That would be 6 inches. All right, well, this is basically what, so you can add them up and get H, but you need to know the ones we skipped for that, okay? Now the midpoint formula. So to find the midpoint on the number line, if you look at the number line, how do we find halfway? Like for instance, if you're looking at 2, 3, 4, 5, point A, point B. So what's M, which is halfway between A and P, midpoint of AB? Well, you can see halfway we can count is at 3. And actually you can get the 3 by adding the endpoints and dividing by 2. 1 plus 5 over 2 is 3. That's the midpoint. So basically you're doing the average. So if I say find M, where M is the midpoint of AB, and I don't give you any numbers in there, so you just say M is what? A plus B over 2. Okay, it's the average. Now on the rectangular system of coordinates, to find the midpoint, so you're given 2 points, A and B. A has x1 and y1, and B has x2 and y2. And we want to find halfway. So to find the x value, which is halfway x1 and x2, this x is x1 plus x2 over 2, and this y is y1 plus y2 over 2. That's what the formula comes from. So the midpoint formula, you add the x values, divide by 2, you add the y values, divide by 2, and that's going to give you halfway on that line segment. Page 797, number 58. Page 797, number 58. It says find the midpoint of the line segment with the 2 given points. So make sure you read the question, because sometimes they ask for midpoint, sometimes they ask for distance, sometimes they ask for the Pythagorean theorem. So for 58, they want the midpoint of the 2 points, 10, 4, and 2, -2. x1, y1, x2, y2. So M, the formula, x1 plus x2 over 2, y1 plus y2 over 2. So 10 plus 2 over 2, 4 plus -2 over 2, 6 over 2. I'm sorry, 12 over 2 is 6, and then 1. That's the midpoint. If you plot these 2 points, halfway is going to be right there. 62 from that same page. The 2 points are -4, -3, and 4, -8. Again, x2, y2. So we add them up and divide by 2. Add the y values up and divide by 2. So -4 plus 4 is 0, 0 over 2 is 0. And -11 over 2 is -5.5. Now 64 is a little different. In 64 they give us the midpoint. 64 page 797. It says if 6 negative 5 is the midpoint of PQ, line segment PQ, and the coordinates of Q is at -5, -8. Find the coordinates of P. Let me just draw a picture so we understand what's going on. So we know the midpoint is at 6, -5. This is the midpoint. Usually we have to find the midpoint, but we're given the midpoint. And we have one of the endpoints. Q is at -5, -8. -5, 6, 7, 8. This is one end of the line. So we want the other end, which is going to have to be on this side because M is the midpoint. So somewhere there, P. And P has X and Y value that we have to find. Well, we use the same formula, but we're given different values. So to find the midpoint, we add the values of P and Q. So -5 plus X. We don't have X over 2. And then to find the Y value, we do -8 plus Y or Y2 over 2. Now we know this equals what? 6. And we know this equals -5. So we have two equations. We can find X and Y. So -5 plus X over 2 equals 6. -8 plus Y over 2 is -5. We times by 2 to get rid of the fraction. -5 plus X is 12 and 5. X is 17 times by 2. -8 plus Y is -10. Add the 8. 17, -2, which looks right there. P is at 17, -2. Okay, you can see it, that makes a lot of sense. And that's it for 9.6. So until 9.7, see you then.